Well, welcome everybody to this Bander Center event. So the Bander Center for Medical Business Ethics is an ethics center that's housed in the School of Medicine at St. Louis University that focuses on education and research about issues in medical business ethics. It was established in 2007 based on a charitable grant from Dr. Stephen Bander and the BF Charitable Foundation. So we have an educational mission, a scholarly arm, and we put on events like this one. My highest hope is that someone here today will get a spark from something that was said, or meet someone compelling to collaborate with, start a project, network, invest in something worthwhile, start a company, change the world for the better. I am thrilled that my guest today is Dr. Philip Alderson. Phil Alderson was born in San Francisco, California, and raised in St. Louis, Missouri. He earned his bachelor's and medical degrees from Washington University in St. Louis and completed his residency in nuclear medicine and radiology at Washington University School of Medicine. Phil was formerly an associate professor of radiology and environmental health sciences at Johns Hopkins, professor and chair of radiology at the College of Physicians and Surgeons of Columbia University, and dean of the St. Louis University School of Medicine, and Vice President for Medical Affairs at SLU. During his career, Phil conducted basic radiation research for the Defense Nuclear Agency at the Armed Forces Radiology Research Institute, worked closely with the departments of Biomedical Engineering and Biomedical Informatics at Columbia University, and served as the president of several national and international medical societies, including the American Board of Radiology. He also served on the NIH Advisory Council for the National Institute of Biomedical Imaging and Bioengineering and NIH Council of Councils, and served as the chair of the Advisory Committee on Medical Uses of Isotopes of the U.S. Nuclear Regulatory Commission from 2015 to 2018. Dr. Alderson, who is certified by both the American Board of Radiology and the American Board of Nuclear Medicine, has over 200 publications, including 4 books, 40 chapters, and over 150 journal articles. He has made more than 200 presentations at local, national, and international meetings, including 10 named lectureships, and is listed in Who's Who in the World, Who's Who in America, Who's Who in American Education, among others. In January of 2017, Dr. Alderson began a 6-month sabbatical at the NIH in Bethesda, Maryland, where he explored the frontiers of biomedical informatics and big data science in the Lister Hill National Center for Biomedical Communications, an R&D division of the National Library of Medicine. Dr. Alderson resides in St. Louis, Missouri with his wife, Marjorie. They have 2 children and 5 grandchildren. And in full disclosure, Phil is also a member of our Bander Center board. So, Dr. Alderson, welcome to the Bander Center.
Thank you.
And thank you for being with us. Artificial intelligence is a real buzzword these days.
Sure is.
Just open up the newspaper and you'll probably find it mentioned, if not deeply covered. I was thrilled to find out that you've spent the last year or even more focused on artificial intelligence, especially the ethical issues behind artificial intelligence in healthcare. This topic really generates some fundamental ethical issues that go right to the heart of what doctoring is, and even maybe what being human is. So can we start off with maybe just if you could just give us a general overview. You know, what is the state of artificial intelligence in healthcare? More basically, what is artificial intelligence? What are we even talking about here?
That'd be a good place to start. Well, this is a field that has been with us really for decades and decades, although you wouldn't know it because it seems to have changed a lot recently. And what really happened were some technological developments that came along within the last really 5 or 6 years. Around 2012, things really started to change because in medicine, which is one of the latter fields to get involved in this industry, the human genome was sequenced back in 2003, opening up a whole potential for tremendous new biological insights into health and disease. But the data sets were enormous. They are enormous. The genome has 3 billion pairs for each one of us and each one of our cells. Enormous amounts of data, and couldn't really be handled by standard approaches. Along the same time, Along were coming all these computer technologies that really weren't quite fast enough, quite accurate enough to work until, as I said, around 5 or 6 years ago, when the so-called deep learning came to be. What is deep learning? Well, up until that time, what people had designed as sort of artificial neurons or artificial small systems to look at data had been very shallow, and they hadn't been able to put lots of data together or do it all at once. And then around 2012, people began to perfect different ways to move the data quickly through these systems, and they built a lot more transistors into them. So instead of being a little shallow, narrow system of input to output and a few things in between, all of a sudden they started to look like large matrices. So they were 10 deep and 10 wide. And when the systems got that way, each one of those nodes in those systems had input from all the nodes that were next to it in the next row and got a lot more information about what was going on. And the improved electronics allowed the signals to be moved more quickly through that system, so things could really be put together quickly and looked at on the other end. Those developments really made a big difference. Then some computer developments came along that let things go even faster. Rather than using central processing units only, a company called, and this is, I have no interest in this company, but it was their invention, called NVIDIA, N-V-I-D-I-A, developed a GPU approach, a graphic processing unit approach, that they could connect to the CPU and then divide the data coming up into all these parallel streams that could be processed simultaneously. So the combination of the CPU with the GPU really let things start to happen quickly. Almost at the same time they were developing that, people in science were developing new and much better ways to sequence the genome a lot faster. So that's called next generation sequencing or massive parallel sequencing. So altogether, those things were happening and really coming to fruition around 2012, when at some national engineering contests that these people like to have in computer science, and to see who could do the best job of going through some simulated complex data sets, it was the deep data sets, the ones that had depth and not just shallow data sets, that were really winning all the competitions. And over the subsequent several years, as the data sets got larger, the accuracy of the systems got better. Now, this isn't health and it isn't human beings, but it's going on in a simulated environment. But that technology then began to be applied widely in our world. And we carry it around with us all the time. I'm sure you all have your cell phones with you right now. You use them all the time. There's lots of conveniences that have been generated by big data. It's very fast. That's nice. It's convenient since we can carry it around or have it in our laptops or other things we carry with us or have at home. It's really made a big difference in a lot of activities of daily living, and that seems wonderful. And so now that it's really starting to be used in genomics, and the idea of real precision medicine is real, and by precision medicine I mean being able to potentially in the future look at each individual person, know their own genomic constituents, and try to match therapies to the things that they're actually susceptible to or could respond to. You know, it's unfortunate there are some data relatively recently, 2 or 3 years ago, that showed that a lot of the current very successful drugs that are marketed over the counter, that maybe only 5–10% of the patients who actually take those have a genetic constitution that makes them reliably going to be helped by those drugs. And it's unfortunate, but that's the way things worked. Your doctor didn't know either. He said, take this blue pill or this pink pill because this is what the studies say works. But he didn't, or she didn't say, it's because it'll work for you. It just works generally. Well, that's the difference between precision medicine and really the current state of the art of medicine today. So we hope that all those things can come together and work. And why wouldn't they? Well, when you think about a game, a contest at a computer meeting or an engineering meeting, Or you think about some of the ways that the computers and big data now make our lives more convenient and better. You ask yourself, what are the downside risks of using those technologies in these circumstances? And so I'm not going to talk about driving cars yet because there are some clear downside risks in that one. But are there really terrible downside risks? Well, maybe you'd say no. But what if now this is going to be used to do health care? And it's going to be used to decide which therapy you're all young people, or your parents, one of your parents gets when they develop cancer. And they're going to use this to decide that. Is there any downside risk to that? Risk that you would care about? Well, the answer starts to be, well, yes, there is. There really is a downside risk. I wouldn't want my mother or my father to be subjected to a mistake made by a computer program. And so I'd like to know more about it. And that's where the ethics start to come in. How do you design these programs? Because if you're going to do ethics, you have to design your algorithm, your line-by-line computer instructions to include those ethics. How do I design this? How do I use it? How do I follow up? How do I make sure that this program, which is supposed to have the ability to adjust over time and get a little better, they call that learning. It's not really learning. It's just the reweighting of some different transistors in a big computer network. But if it can change over time, is it changing for the better? Is it changing for the worse? Did something else happen in the meantime? Did somebody who has nefarious intent, actually somehow wirelessly get into this system and change it? How do we know? What about that surveillance? All of those things need to be thought about when you start to build these systems for healthcare. So I think that's really the essence of the new dilemma that we face when we talk now about the fact that over these years immediately ahead of us, and probably for decades to come, there will be a significant artificial intelligence impact on healthcare worldwide.
No, thank you for that, Phil. I think that was a really nice, in-depth summary of what AI is. One thing I want to start talking about is that decision-making process that goes on in artificial intelligence. That, some people have mentioned this thing called a black box phenomenon in artificial intelligence, and I think let's go right to that, because I think when you're making decisions and you have this black box phenomenon, that really creates a lot of ethical rub.
Okay, well, certainly it does.
What's black box?
So what does the black box mean? So let's go back to a moment ago where I was describing that in about 2012, people started to build these networks of nodes or transistors that were much bigger. They were deeper and they were broader, so there were a lot of them together. Well, so what you have in a system is you have the input side. That's whatever you know when you start out. Over here you have the output side, which is the answer you want to get, which is sometimes a yes or no, or sometimes a probability of something. And in between, you have this large group of nodes that are going to try to weight the possibilities and help decide which one matches the best. In that big group of nodes in the middle, to be called deep learning, it might be something as simple as 3 or 4 layers deep, but generally it's much deeper than that, 10 plus layers. Could be 100 layers. Some of them have been as big as 1,000 layers. All of that reweighting of these different nodes in that system, trying to refine the input into determining what the output is or should be. When you ask scientists, why did the computer actually reweight something in a particular way at any one of those given nodes? Even data scientists, the people that build these systems, they don't know the answer. And they freely admit that they don't know the answer. Now, there are some types of systems that can do a little better than that. They aren't quite as fast, aren't quite as accurate, but the differences are small. So, for example, if you, instead of using simply a simple, deep, broad neural network, you use one that's based on a design approach called a decision tree, where what happens is there's various branching points throughout the process of getting to the answer. you can actually program those relatively straightforwardly to tell you almost at each one of the junctures why that particular decision was made, why it went left instead of right. And that can go on down through a long, deep, random forest, they call them, of these types of networks. So you have some sense there what's going on. But when you just put yourself into the big matrix, there's a reason that the scientists who develop these things call those the hidden layers. That's what they call them, the hidden layers. I thought that was some sort of a strange term when I first encountered it and said, well, obviously I've got to find the answer. Why are they, what's in there, you know? And the answer is, well, nobody knows just yet, and they don't know how those work. But some people are willing to say that we're willing to accept that. You know, we can accept that. If the outcome is what we want it to be, then we're willing to accept that we don't know exactly how it works. But a lot of other people aren't willing to accept that. And we have to worry that those systems, if we don't know how they're working, they can have inbuilt biases. They can actually have incorrect data. They can change as they're evolving to have been good at one point and not so good anymore. So there's a lot of challenges that we need to think about when we start using these in healthcare.
Right, I think so. I mean, you know, I'm thinking about decision making and ethics in general. You know, we kind of think sometimes we want to actually look at that decision making process. The rightness or wrongness of an action might like rely on the decision making framework and the mechanics of the decision itself. You know, so how do we mesh those two things? I mean, on one hand, we want to create AI systems that have ethics embedded in them. On the other hand, we might not be able to see the decisional framework. So do we just leave that decisional framework part of the ethics behind, or?
Well,
that's a hard question.
Again, some people would say yes, some people would say no. And I think most people might say that they'd be willing to consider a risk-benefit ratio approach. You know, what losses are we likely to achieve and what benefits are we likely to achieve? So here's an example. One thing that happens, unfortunately, to all of us and to all of our loved ones is that time when the end of life is near. And frequently when people have serious illnesses, it becomes obvious that despite all of the benefits of modern medicine and modern chemotherapy and what have you, that the patient really isn't going to live through this. And sometimes those people go to hospice, which is a particular type of medical care where they're supported. Well, you might think that the people who make those decisions about hospice, the doctors, are pretty good, you know, at seeing their patient. They really know their patient, and determining that the time, if this patient now, I can recommend going to hospice, probably in X time, there's a pretty large probability that they will pass away. Well, it turns out that that's not true. It turns out, whether it's because of whatever, the emotional involvement the doctor gets, just the whole fantastic complexity of biology, I don't know, but doctors aren't very good at that. But it turns out that algorithms are. Now, they're a lot better at that. So some people, and there's a study recently at Stanford, Stanford's done some very good work in the whole field of AI and healthcare, where they've shown that using a deep learning algorithm, they can actually predict with much greater accuracy how long a particular patient with a particular constellation of biological findings and social findings, et cetera, is going to live. So the doctors at Stanford, some of the doctors working with this, are saying that they can accept that. You know, we don't really know exactly how this deep learning algorithm is working to make this decision, but the fact is it's making it well, and we believe that the benefits of us knowing when a patient should go to hospice, how to treat that patient in hospice, that's all a lot better than some of the things we used to do and the mistakes we made. And I guess in this case, since the inevitable outcome is the same, that the issues are mostly upside. You know, so they're willing to go with that, and they're really starting to use it, and I think it'll be used more widely in this particular regard. But that wouldn't be the same as making a decision for a child who has cancer. And you'd want to know exactly what you were doing, or at least I think most doctors would, and they would want to know why the decisions were being made. The parents would want to know why the decisions are being made, because as we know, even given the best knowledge, that match that people try to make between the chemotherapy and the patient doesn't always work. And sometimes, people escape the chemotherapy and they have rebounds and they have to go on something else. I think people would want to know, in that other instance I've just created, the child with cancer, why those decisions were being made. So when you have to make the second decision, or the third if you do, that you've seen the path you went down, it didn't work out well, you've got a little better idea of how to go down the next path and do it the right way. So that's an individual decision, that risk-benefit ratio issue. But I think that most people would prefer to know in the latter example, and might be willing to go along with the idea that they don't quite know in the hospice example.
Yeah, I want to go kind of with something that you said a little bit earlier on.
Okay.
And I'm thinking about the humanness of decision making, right? So you mentioned the emotionality involved with decision making. And in fact, I think you were kind of saying that might lead doctors to make wrong decisions. Is it going to be possible for AI to incorporate an emotionality or a human likeness, or the emotionality arises because the doctors are human and the patients are human, right? And or are we going to lose something with the emotionality, or is it just a good? I mean, to have a emotionality bereft decision making,
right?
Machine.
Well, at this particular time, I think it's fair to say that the computers that and the systems we deal with have no emotionality context at all. It's unfortunate in some ways that the way we talk about computer systems tends to speak about computer systems as if they had human characteristics. The computer reads the data. The computer sees the image. The computer thinks this or does that. They are machines. They are very carefully programmed. The only kind of artificial intelligence, that in itself is not a good term in this sense, that happens is because they have line-by-line instructions, that so-called algorithm. And they, as a machine, follow those instructions. Now, they don't really create new ideas out of those instructions. They just keep following them. Now, the instructions say to do better and better, see, I did it. I can't not do it either. But get better and better at the closeness that you come to this answer. And so they're programmed to try to reweight all these nodes in their system in such a way that they get to the ones that are helping it make a better decision, and they keep using those over and over. But they aren't doing things that are human in that sense. So in these systems and in the ethics of these systems, one of the things we all worry about is that they are said, once they start going back and forth through their network, forward, 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 or forward and reversed at the same time, back propagation, which is a very powerful way to reweight the system effectively, they can become semi-autonomous. They can become almost virtually autonomous and just keep cycling back and giving a better and better answer or a different answer. Once they're somewhat autonomous from the human beings, then there's no moral imperative at all. So that's one of the reasons that people are concerned about artificial intelligence, deep learning, as it's applied to medicine, because it won't have a moral imperative. Now, it doesn't mean that when you go out and read about computers, I hope you all realize that unless you're very careful at how you pick what you're reading, that most of what you read is an advertisement. And it's written by a company that wants someone who reads it to buy what they're selling. And so they're always very positive, very upside, using very broad and very exciting language about the potential of their system and what it can do for you. But it's still just, they're just selling it. So if you want to design in ethics in a system and you don't want to do it from the beginning, you get down to this issue of how these decisions are made. And that is something that if human beings are going to be in some way responsible for the outcomes, they've got to have some input. Yeah. They've got to have some oversight of those systems, or there is no moral imperative for those systems. So that's why people are beginning to talk so much now about really getting in front of this to design systems from the beginning that are built in with things you can trust, things you can trust. They are transparent enough that you can understand what's going on. They are theoretically unbiased. They are safe. They have relatively low risk. They are trackable. That once they're doing things out there, you can get in and test it in some way and see what was going on. And these sorts of ideas are not found in many of the systems that are operating today. They just aren't there. Because there's been such a rush to get on the economic side, the business side of what's going on. There's a lot of money to be made here, folks, a lot of money. That the ethics side and the difficulty of building in those kinds of aspects into the systems has been a little bit left behind. And people are starting to come around now, not the corporations particularly. Oh, I shouldn't say that, because the corporations would probably say that they're deeply concerned with the ethics and morality of their systems. And ultimately they will have to be. But it's just starting to catch up right now.
Yeah, wow. I think other things in that category, that differentiate. I'm going to ultimately ask you if you think that AI is going to change what a doctor is, what a doctor does. But I want to just do a little more preliminary stuff.
All right,
Okay,
sure.
So it's like, my decision making as a physician has to do with the fact that I have a body, right? I'm an embodied brain. I'm not just a brain in a vat, right? I think I've had pain. When a patient says pain, I can know embodiedly what that is, I guess. Medicine is often a response to human suffering, seen as an opportunity for humans who want to alleviate that suffering, right? There's this underlying course of doctoring, which is this kind of opportunity. Is artificial intelligence going to somehow obviate the need for a caring attitude? How can AI be a force for good, given these things?
Well, because the main strength of artificial intelligence systems is they're able to assess these complex data sets with which we're now presented in healthcare, and do so extremely quickly with really relatively high degrees of accuracy. That's why AI can be a force for good. And, I don't know how many of you are in medicine or are thinking of going into medicine or healthcare, but there are a lot of people, a lot of physicians now in healthcare who are a little frustrated with their profession. And it's because of the tremendous burden that they face to do electronic quality control, to verify on a daily, hourly basis all the things they're doing in electronic health records. Electronic health records have become, again, over maybe the last 10 years, widely used in medicine, almost everywhere. We use them now, certainly wasn't true 10 years ago. They were not, those health records were not built to stimulate better emotionality of medical care. They were built, and hospital systems really loved them because they were built really to follow the dollars. They were built to really optimize billing in healthcare. Everything else had to come along with it, but they were optimized for billing. And they're pretty good at tracking billing, they are. But they're a little, if you'll pardon the use of this computer term, clunky. Even the good ones. We have a very good one here, one of the two most highly installed systems in the country. And it still has its clunkiness. And those things are very bothersome to physicians who will talk about meeting with their patients during a day and wanting to have the sort of personal contact, eye contact, renaissance with their patient that they always wanted to have, which is why they went into medicine. But in fact, if they're not over here typing on the keyboard, putting lots of data in, they won't even come close to having that health record completed, and it has to be completed. So what happens with a lot of physicians is that they try to spend their day, if they do, focusing more on the patient, and then what are they doing at 10 o'clock at night? They aren't getting into sleep for the next day. They're sitting in front of a computer now completing all their healthcare records from the previous day. That's terrible. That's burnout. That's a big problem in medicine right now, and it has to be resolved. So I think that this is one of the things that I really hope will come from all of the attention now and the potential profit that exists in the area of medical artificial intelligence, is that someone will figure out a way to smooth and enhance the efficiency of this interaction between the doctor, the patient, and the electronic medical record in such a way that we can get back to the doctor having to spend less time on these standard repetitive tasks of medicine and more time on the humanistic task in medicine. And I think that's a real possibility. And when we look at the upside of healthcare, the upside of artificial intelligence in healthcare, that's really what we're looking for. And that'll be the early input. It will start to take away some of these repetitive tasks and let that doctor spend more time talking to and working directly with his patients or her patients.
I like that. I mean, so it's your thought that it's not going to change what a doctor is at its root. It just makes the doctor job more doctor.
Well, right now it's making the doctor job more difficult. But I think that in the future it could help make get the doctor back to what doctors were, 40 years ago in terms of the humanistic quality of the field.
Yeah. Let's do one more question, and I think then we'll do an audience kind of interaction, if that's okay with you.
Fine.
I mean, I want to talk about, this fact that the substrate, the inputs, right, very much determine what the outputs are. Right. Even in a black box type AI situation, no matter what kind of AI situation you have, the inputs really determine the outputs. So is it possible that there'll be bias introduced into the system just from the inputs themselves? Sure. Maybe even bias you cannot see. I think you kind of painted a picture of, can we get to a point where we have an unbiased AI? That would be nice, but really, like, we live in this biased world. So if you put an unbiased AI in our biased world, how does that gel? I mean,
well, one of the issues that is most problematic in artificial intelligence right now is the data itself. And when you listen to people who've worked on large projects be asked about the proportionality of their work effort, I've heard on 2 or 3 occasions someone say 75 to 80% of my work effort was just cleaning up the data. So first of all, the data, because the health record, the EHRs, they aren't engaged at all in creating clean data. They're in storing data in various different databases within whatever is that healthcare system, and then just putting it back out when a command comes that asks for it. So the data can be incomplete. They're often incomplete. Sometimes they're contradictory, and the data are very problematic. And yes, and beyond that, the data themselves could be biased, and there are a number of examples of that, where in collecting a particular study, it was done, let's say the study for a particular disorder happened to be done in a community hospital somewhere or a medical school that's in a suburb somewhere. And so it turns out that the study is populated primarily by white men over 65. And now you take that study and plug it into an artificial intelligence system, and will that system, even if it's doing a wonderful job looking at all the variables, will it come out with an answer that's applicable to today's modern multicultural societies? Not much chance that it will. So that's a kind of bias. Now, there could be even other biases, and we don't like to infer negative intent, but for example, if an organization with a commercial interest was particularly interested in having its sort of product be used by and be favorable to people who were better off and could afford to pay big prices for particular editions of that, it could develop an algorithm that in fact was biased toward people of that type, which would make it totally inapplicable, say, in the inner urban city. And those sorts of biases could be hidden. And so we have to be very careful. It's again on the data side. When our people talk about cleaning the data, that's part of what they're trying to look for. But you can't always see those biases. And so when you start building systems that are ethical from the beginning, you're going to talk about this, and you're going to build that kind of an issue into some of the algorithms that are going to do surveillance over the algorithms that are being used. And you're going to have that trackability. You're going to have to be able to watch that algorithm work, see what comes out, determine its accuracy, its reproducibility, its validity, and determine whether the answer keeps coming out the same way. I haven't been able to find anyone yet who's really developing systems that really do the spectrum, starting from the beginning and trying to build an ethical system and going all the way to the end with a system that's going to have great trackability and be strong in evaluating how this system performs over time. And the other thing I've noticed, it's kind of a little worry, I guess, for us here in the United States, it's some of the best work that's being done in the most active areas right now. And these are all references that come from the last couple of years. They're in Europe.
Yeah,
they're in
interesting.
Europe.
That's interesting.
They're in Europe. And the United Kingdom is doing some excellent work in this area. I think they've been ahead of us in artificial intelligence and healthcare for several years. The European Union and its ethical branch have done some very nice work and put out some very nice documents recently. And again, the U.S. is keeping up. There's a partnership for AI that's really concerned about these ethical moral issues. And it doesn't have many partners from many different spheres within our culture and around the world, 10 different countries. But still, I think the real onus for moving forward on this in a major way, and some of the best new ideas are coming from other countries. I think the Food and Drug Administration, which is going to be responsible for a number of these issues and approving algorithms. By the way, I don't want to forget to say this. An algorithm, the line-by-line instructions that really is all the computer knows, those algorithms by the FDA are considered medical devices. It's a medical device. And so the algorithm must be approved by the FDA through its medical device programs, just as other medical devices would be, like a new magnetic resonance imaging machine. Now, there are different tiers of medical devices, and some of the algorithms, depending on what they're doing, might be at a relatively, modest tier, but others, are higher. So the FDA is working hard to try to get its hands around this, and they've got a new, relatively recently developed program called the Medical Device Development Tool. And it's a step-by-step process through which everybody presenting a medical device, whether it be a magnetic resonance machine or a computer algorithm for healthcare, should go through and try to match that up. And there are organizations, some of which I'm familiar with because the American College of Radiology is doing a good job of trying to get this going at the same time to work with the FDA and are trying to sink into these approaches, which I think are going to be excellent, but they're not fully developed at this time at all, and I'm really glad to see the United States starting to perhaps catch up a little bit.
Yeah, that's really interesting, Phil. Thank you so much. Thank you for joining us today. I would love to open this. This is ethics. We firmly believe that ethics is a discussion, not a lecture, right? So we have a great audience. I don't know if there's anybody who has a question, and make your question detailed if you'd like. Sure. I don't know. Is there anybody? Yeah. Jason Eberl. Thank you.
Thank you, Dr. Alderson, for a wonderful conversation, for Jason for organizing this. I was really intrigued by what you said, which I did not know, that the FDA classified the algorithms as devices. Of course, new drugs or medical devices have to are subject to the Code of Federal Regulations governing research with human subjects. So could you talk a little bit about the process by which these artificial intelligence systems are being tested and overseen by IRBs and things of that nature?
By IRBs, so the question was, I hope everyone heard that. So how are these algorithms being overseen by IRBs and so on, by research organizations that are interested in quality and controlling the approach to research? It's my impression. Now I am giving you only my impression, so I can't quote a source or whatever. My impression is that many people around our universities and corporations these days are not aware that algorithms are medical devices. And they are just developing them and applying them. So I don't know. I don't really know how IRBs are looking at that. But one can imagine that you need to develop a whole approach for IRBs to begin looking at anybody in their campus and their community that's developing or perhaps even using. This is an interesting question. There's no answer to that one either. An algorithm regularly in its clinical work. How do we have to, who has the liability for the use of that algorithm? That in itself is an interesting question. A lot of people are debating, and they think it may need to be some sort of shared liability. There's a company that made the algorithm. There's a doctor who's applying the algorithm. There's perhaps an organization or a university that's, in which that doctor is a member. How is that liability spread? Is it spread? Do they all have a liability? I personally, I would be darn well sure that I knew what was going on in that algorithm, or I wouldn't want to use it.
Right.
Now, I don't know how other people feel about it. If I were a patient and they told me that we're going to decide what's happening to you, how did that work, Jason? I don't really know, but it's deep learning. It's supposed to be pretty good,
Right,
It's a good company. They say it's great, See you later, Jason.
Right, yeah.
So
I can imagine a future with you can go to see the non-AI doctor, right?
Yeah.
I'm the human, I'm the natural doctor.
There you go. There you go.
Okay, I don't know, is there someone else? Is there another thought in the audience?
There's a hand in the back there.
I see a hand in the back. If you could introduce yourself, that would be great. Thank you.
I have an interesting background. I came from science before I went into the bioethics PhD, up through actually Bill Sly's lab here at SLU. And it makes me wonder, when you talk about building an ethical system, the computers, they see quantitative data mostly, maybe a little bit of qualitative data that's been scored in a quantitative way. And ethics isn't always that. It's much more complicated. Is there even a way to build, you talk about tracking and all of that, but at the end that puts the onus of the ethics on the humans, and then you run into the black box problem as an aside. Can you really build an ethical system knowing that ethics itself is not data? Or do you end up with something that's kind of a bad utilitarianism?
Can you build an ethical system? It's a really interesting question. I think that, I think you probably all know who Alan Turing was, a very famous man from the UK who was one of the early pioneers in computers. He was a little worried about this question about whether you could build a system like that, but he thought the systems and autonomous systems could kind of run off and do things on their own that you didn't really like. And so he sort of, perhaps half jokingly, but he said, well, you ought to design in so every once in a while it just turned itself off. You turned off all the electricity, and down to ground zero and had to reboot. I think that there are some concerns. Can you build ethics in? Well, you can build in whatever you can write in code and get into the system. So you could build in that it had to relook at what it was doing. You could build in certain approaches. You can't really build in emotions, but I want to make a comment about the fact that you can simulate emotions. And there are actually people working now, this is called affective computing, who are working with actors and actresses, and they are getting them to use natural language processing, and the fact that that the computers relate to audio also just because they can see the patterns that are coming through it. But so getting actors and actresses to effectively represent certain emotions, and then training the computer about what those emotions were and how to respond to those particular signals. So I think that people are ultimately potentially going to simulate some things like that. But I think that Dr. Turing was probably closer to right. Once in a while, you're just going to have to interrupt what's going on and try to set things back to a ground state. But it's a very challenging issue.
Yeah.
There's a hand way in the
There's
back.
a hand in the back. I usually like to give the audience person who asked the question a chance to kind of respond. I don't know if you want. You kind of imply your question. And then, we'll definitely get one from the back there. You kind of imply in your question that it may not be possible.
Well, I mean, even with what you talked about, that's still reducing a complex human to a bunch of data endpoints. And I'm just wondering if we lose something. You talked about being an embodied mind, if we lose something, especially if you come from a Catholic tradition where we're not just, materialistic data point, if that gets lost in the way, and if that ends up in, we start applying this to population levels especially, reducing humans to just economic units.
Well, our talking about reducing humans, I mean, our computers, these computers reduce everything to zeros and ones. And that's all it is. That's all it is. It's zeros and ones. Well, how can complex data become just zeros and ones? Well, because you can operate in bytes, and those are about 7 things long, and then you can put bytes together and create longer things. You can figure out pretty soon mathematically that you can represent just about anything you want and ultimately get it down to zeros and ones. But in today's computing, and what we have today, we only have narrow artificial intelligence. It's all anybody has. It follows instructions and it gives answers, and it's trained to do only usually one thing. Trained to do one thing. And that's all it does, is that one thing. And the answer may be a binary. Maybe that what you said, what the data you gave me matches or doesn't match, yes or no. Or it might be a probabilistic thing. There's a 90% chance that the data you gave me represent this. Usually they're trained with data or an image or something, and that's called supervised learning. And they're just trying to match up to that thing. See if what new data you give it matches what they were trained with, or is this a lung cancer in this CT scan, or is it something else? Sometimes they just look at all data and they cluster the data, and then that can be related to another standard to determine what the clusters are. But that's all they do, that supervised learning and unsupervised learning. Will we ever get beyond that? Well, general artificial intelligence is defined as when the computer can take in the whole breadth of experience that human beings have and relate an answer to that whole group and do that at least as well or better than a human being across the board. That's general artificial intelligence, and that's nowhere on the near-term horizon. Yeah. But what you can do, and I just want to answer one question. They're like, they want to answer. They're saying to themselves right now, yes, I hear that, doctor, but how can a car drive itself with what you just told me? Well, the fact is, what you can do with narrow AI systems is you can patch them together. And so that's what happens in self-driving cars. You patch together a bunch of narrow AIs, and then they're electronically unified, and so it can do a lot of things. It can see the pedestrian and the stop sign and the line down the middle of the street to stay in its lane. Those are different systems, but they're all working together. So that's how we sort of get to where we're going today.
Let's get one more comment.
Sure.
You had.
I'm Anna Rutschman. I'm an assistant professor at the law school at SLU, and I actually teach FDA and biotech. So we look at the legal and policy issues of many of the things that you've been talking about today. And I was just wondering if, Dr. Alderson, I could get your thoughts on the drug discovery side of things. There's a lot of interesting things happening there with narrow AI. And I was just wondering if you could share your thoughts about the ethics of drug discovery in general using AI technologies. Is it different from what we've been discussing so far? Because there's this sense that a lot of what we can discover now that we've discovered all the easy drugs, all the easy druggable things, is that a lot of it is just luck, right? That's involved in coming up with the right compound. So if it's a computer doing it instead of us, do we really worry as much about ethics in that field? And if we do, what's special about it from an ethics perspective?
Okay, what about drug discovery? That's the question. Why are we now using computers to do this when we could do this, and are there any ethical aspects to this? Drug discovery, a really interesting question, particularly here at St. Louis University. When I came here a few years, 10 years ago I came. One of the people that approached me shortly thereafter was a scientist named Pete Ruminski. This is about 2 years in. And he said, you know, drug discovery, he was not into AI at all, but in drug discovery, he said, is really important because what happens is that the drug companies, they've got all these possible drugs in the pipeline, and they're all going in parallel, they're all being developed. And most of them fail. They just don't ever make it to market. And then they put those all in a storehouse somewhere, or they just put them on the shelf, and they go on and develop other things. But he said, Pete, worked in that industry, and I know that's out there, and I have some great scientists want to work with me and come to SLU, and we want to actually go out and partner with these companies and look at their not used, not commercially active files, and find things that match up to other diseases, and really make them work. And they did come to SLU. And they were here for about 6 or 7 years, and they had very good success in a number of ways. The Center for World Health and Management, something like that. I've forgotten exactly what it was called. So that is exactly, as I understand it, what AI now does in drug discovery. Because now there are electronic files of what those companies all have out there, and so if you're willing to turn loose an algorithm on that very quickly, it can go through things that may have taken Pete and his colleagues, a year or 2 years or a lot of time, and then some verifiable experiments to do. It'll go through and do them in a week. I don't know if that time is right, but in a very short time. So the ability of AI to look at huge amounts of data very rapidly is a big advantage potentially in that kind of drug discovery. So I'm going to be interested to see what happens there. I don't know that there's any ethical issues in that drug discovery process that don't exist as we've already described it. In other words, if the drug itself was appropriately studied in the first place and the data there are sound, and now we're just trying to find a better match to a disease where we now know the genomics and say, this particular protein which this drug might treat is important in this disease. We didn't know that before. I don't see there's probably going to be too much of an ethical problem in that matchup.
Hi, I'm Emily. I'm an undergraduate student here. And I was just wondering, so often doctors go on the stand in court for like expert testimony, and they can be taken as even more credible than they might be. And so do you think that AI will soon become an expert testimony? And do they have to have an ethics capacity to make, to contribute to a ruling on someone's morality?
Okay. So will AI actually be active in court, and will AI be used as an expert witness? And what impact will that have? I doubt that the way I think that could happen is that you'll have your witness, the human being, who is saying things, but the opposition and will have already studied what's out there and may have gone to artificial intelligence to find an answer. And what will come back at the witness who is professing to be an expert is, well, doctor, are you aware that these studies from our artificial intelligence review of the data show that what you just said to me is not really correct? Are you aware of that? And now the doctor may be aware, and then you may get into an interesting debate, or they may not, and then AI may just win the day, and the jury may say, AI. I don't know.
That's a great question. Well, thank you everyone for coming. I'd like to announce that we are in planning stages of an entire conference on this topic, which we're hoping to hold in November of 2019, about a year from now. We'll have at least one, if not 2 days here in St. Louis devoted to dialogue, talks, exploration, art, and so on and so forth about artificial intelligence and healthcare ethics. If you'd like CME, please find your way to the CME sign-in sheet, which is right over there. We also have parking passes available if you parked in the parking garage. We encourage everyone to sign up for our Bander Center email list and stay tuned for future events. On Friday, December 7th at 10 o'clock in the morning at the Bush Student Center, just across the street, St. Louis University ethnographer and bioethicist Harold Braswell will interview healthcare advocate and activist Wendell Potter about the economic environment of medicine and arguments for single-payer healthcare. If you're interested in donating to our center, we would love to talk to you about that. And if you'd like to become more involved in a different way, we would welcome that too. So I'd like to thank KETC Channel 9 for the audio and video recording and producing the video version of this event, which you'll find on YouTube in the next several weeks. To our staff, including Gunnar O'Brien, Denise Webb, and our med student managers, Matt Gracka, Annie Seskleifer, and Jeff Carbonella. And to everyone who showed up and participated in the dialogue today. And of course, thank you to Philip Alderson. Please join us for a drink and a snack and talk to us. Continue the conversation. Try to talk to somebody you've never met before. This is an opportunity to network with a group who has come together for ethics. And so have a good time. The bar will be open for about an hour, and thank you for coming.